In this example, we have that the mean height of American males is 176.3. Okay? So we would use that as my null hypothesis. So my H naught is going to be that the mean is equal to 176.3 centimeters. Okay, so it's saying that that's the average height of American males. Okay, so to test that, they collected a sample. Well, that sample is the presidents of the United States. Okay, so what they're going to find out then is, are the presidents taller than the average male? Okay, so the mean is 176.3 centimeters. And so if we want to know that they're taller than, what do you think my alternative hypothesis should be? It's the same, the same parameter, the same number. The difference is that this is either going to be less than, greater than, or not equal to. But since it says taller than, that indicates greater than. Okay? So, so we're trying to determine if U.S. presidents are taller than. So if I can reject this null hypothesis, then that means U.S. presidents are taller. If I do not reject it, then I say I don't have sufficient evidence to say that the presidents are taller than the average American. Okay? All right, so I took my 44 U.S. presidents, their heights, added them all up, and divided by 44, and that gives me the sample mean. So instead of giving me the data, they're giving me the results of that, right? So if you did this as your project, you would have to add up the heights of all the American presidents and then divide it by 44. Okay, but you're going to have to find a different project than this since we're using it as an example. Okay, so so 44, adding them all up, dividing by 44, this is the average of that sample of 44 U.S. presidents. Okay, and this standard deviation, they already figured that out and gave that to us, is 7.1 centimeters. And again, that's from the sample. That's a sample standard deviation. Okay, determine if the evidence suggests that U.S. presidents are taller than the typical American male. So that's how I know this is greater than. And it says use alpha is 0.05. So what type of test is this going to be? It's a mean. Okay, we're testing the mean.
Right tail.
And it's going to be right-tailed because the alternative hypothesis is pointing to the right. It's greater than. Okay? All right. So we have our mean is 176.3 for our null hypothesis, and that it's greater than 176.3 for our alternative hypothesis. Do not just write H naught equals 176.3. H naught is just like a title for this. It's telling you this is the null hypothesis. That's the null hypothesis, that the mean is equal to 176.3. So your null hypothesis is always either going to be P equals a number or mu equals a number if it's a mean. For a proportion, it's going to be P. For a mean, it's going to be mu. Okay? All right. And the level of significance, that's step 2, is to find the level of significance. So we know that from the problem. Then step 3 is to calculate your test statistic. Okay? So remember for a mean, the test statistic is this one. Okay? And that is on your formula sheet right here. Hypothesis test statistic. It's right under that. Okay, so that's where you're going to find that formula. So you take that formula, plug in the values that we know because they were given to us in the statement of the problem, right? So the mean of the sample, the X bar, was given to me in the problem as 180.1. The standard deviation in the problem was given to me as 7.1. The mean, this is X bar minus mu naught. Mu naught is the one that is in your null hypothesis. So it's going to be X bar minus mu naught is 176.3. So divide that by the standard deviation. 7.1 was given to me in the problem, divided by the square root of n, also given to me in the problem, is 44. So in this case, everything was given to you in the problem. It's just a matter of knowing which formula to use and what to plug in for it. Okay? So once you plug all that in, you should get 3.550. Did everybody get that? Okay, that's your test statistic. Okay, so for the classical approach, you're going to take your graph and you are going to put the alpha on it first. Okay, so my alpha is 0.05, and because it's a right-tailed test, because the alternative hypothesis is greater than, we put that 0.05 to the right. Okay? So then we have to figure out what this t is down here. Okay? So if I know the area to the right is 0.05, and what is my n? 44. So use your t table. Okay, area to the right is 0.05. Go down to 43, right? Because the degrees of freedom are 43. So if you go down, 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 there's a 40, but there's no 43. There's a 40 and a 50. So 40 is as close as we can get. So we use 1.684, okay, from the table. All right, so that's where we get this cut point here, that 1.684. You can also use your calculator to find that if you have a TI-84 plus CE. Not all calculators have this on it, so you can use the table if not. But use second distribution, go to inverse norm, and then put the area. I believe you have to put the area to the left is 0.95, because if it's 0.05 on the right, then the area to the left is 1 minus 0.95. I mean 0.05, which is 0.95. And then the degrees of freedom are going to be 44 minus 1, which is 43. Yeah, so 1.681. Second distribution, inverse T, area to the left 0.95 degrees of freedom. Yeah. Okay. So so that is going to be, if you do it from the inverse T, it'd give you 1.681, but the 1.68 is the same as the table if you round it. Okay? All right, so then I found, once you put your alpha on the table, on the graph, and find your critical value, then take your test statistic that you found, 3.55, and put that on the graph. So remember, the mean is in the middle, positive values to the right, negative values to the left. So positive 3.55 lands right here, which is greater than my critical value of 1.684. It lands in the rejection region or the critical region. So what's my decision going to be? Reject. Reject the null hypothesis, which means what is true? The alternative hypothesis is true. So I reject my null hypothesis, which was that the average is 176.3, which means that I do have sufficient evidence to say that this sample, which is a president's, are taller than the average U.S. male. Does that make sense? Discrimination. Okay, so let's look at the same problem, but using the p-value approach. So you still find the same test statistic. Okay, so this is the same test statistic that we found before. Then you take that test statistic and you put that on your graph. So 3.55, mean is in the middle, 3.55 is to the right. Then you have to find the area to the right of that because we had a right-tailed test, right? So we're looking for the area to the right of that. So if you look at the table, this is degrees of freedom 43. So if you go to the t-table, 40 is as close as you can get. And so we're looking for a cut point of 3.55. So if you go across that row, 3.551 is as close as we're going to get. And that's going across the row of degrees of freedom 40. Then if you go up to the top, that means that my p-value is 0.0005. Okay, so using the table, the closest we can get is 0.0005 because we had to use 40 instead of 43 degrees of freedom. All right, to find it from the calculator, okay, turn your calculator on and then go to, obviously, turn it on. Sometimes I try it without. It happens. Okay, so go to, so we know the cut point. We're looking for the area, right? So we know the boundary. But this is a T, not a Z, so we can't use normal CDF like we normally would to find the area. Okay, so the way we find the p-value then is go to stat, tests, and this is a t-test because of it being a mean, and we use a t-score here instead of a z. Okay, so go to t-test, then put in the stats, because in this problem they told us the statistics. If you have a list of values, then you can put in your data in list 1 and then choose data, and it'll calculate everything for you. So in this case, they told us the mean, so the mu naught is what's in your null hypothesis, 176.3. The x bar is what you got from your sample, which is 180.1, and the standard deviation is 7.1. And my sample size was 44. And then my alternative hypothesis, not equal, less than, or greater than? Greater than. Greater than. And then calculate. So it's going to give you the t value, which is the test statistic for a mean. So 3.55 is what we calculated right here, 3.55. Make sure when you put that in your calculator that you put parentheses around the numerator and the denominator, because otherwise you won't get that. So that's the first thing it gives you when you do the t-test. The second thing it gives you is the p-value. So notice it says when you use the calculator to find the p-value, so you do stat tests, t-test, and then you put in the mean, so stat test, go down to number 2, t-test, choose stats. If the stats are given to you, if not, then you choose data and put your data in list 1. Okay, so then you give it the mean from the standard deviation. Okay, so that's from the null hypothesis. Okay, then you give it the X bar, which is from the sample that you're using to test it. And then you give it SX, which is the sample standard deviation. So this is the mean from the sample. This is the standard deviation from the sample. Okay, then you give it N, the number in your sample. And then you tell it from your alternative hypothesis. So is it going to be not equal, less than, or greater than from your alternative hypothesis? Okay. So since this was a right-tailed test, we said greater than, then we calculate, and that gives us the t, the test statistic, the p-value. So what we got is 4.735500384 E negative 4. So that E negative 4 means to take that decimal that was right here at 4.7 and move it 4 places to the left. So 1, 2, from here, 1, 2, 3, 4. Okay, so your p-value is 0.00047355. Okay, so that's how, on your homework, when it says use technology to find the p-value, you're either going to, if it's a mean, if you're doing a test for a mean, you're going to use t-test. If you're doing a test for a proportion, then it's going to be one prop. You're going to do stat tests. You can use inverse t also, or inverse z to find those values. But so to do the p-value for the proportions, you go to tests, stat tests, and then one prop z test, and put in all your information, and that's going to give you the p-value here. Okay, so that's how you find the p-value for both of those. So once you have the p-value, compare that to the alpha. So the p-value is 0.0005, okay, and that is less than the alpha, which is 0.00. Oh no, that's using the table that it has to be between those. So after you find the p-values 0.005, compare it to the alpha, which is 0.05. So the p-value is definitely less than the alpha. So if it's less, then p is low, the null must go. So we reject the null hypothesis. Okay? So if we reject it, that means that there is sufficient evidence at alpha is 0.05 level of significance to conclude that U.S. presidents are taller than the typical American male. Any questions about that?